In this lesson, we are going to discuss the variation in ionic radius as compared to its neutral atom across period 2 and 3 and also down a group. Later, we will see what is isoelectronic species and how to explain the variation in the radius of isoelectronic species. Variation in ionic radius or ionic size can be discussed into these four categories. The first one is the size of ion as compared to its neutral atom. So we are going to see how does the size of the anion and cation will changes from the size of the neutral atom. So for example, we can have sodium atom. So from the sodium atom, we will see what happens to the size of its ion, that is Na+. So Na+ ini adalah sodium ion, okay, which is cation. And we can also see the variations of the ionic size between chlorine atom and its anion, that is Cl-. Later, we will see the variation of size of the ion across period 2 and 3. And then we will see how does the size of the ion changes as we go down a group. And lastly, the variation in size of isoelectronic species. Before we go into each of the category, let us recall the factors affecting the atomic and ionic radius. In order to discuss the variation in atomic and ionic radius, we have to use these two major factors. They are effective nuclear charge ZEV and shielding effect or screening effect. So what is ZEV? ZEV is attraction force by nucleus that felt by valence electron. So ZEV ini adalah some sort of attraction forces yang dikenakan terhadap valence electron oleh nucleus. So the greater the value of ZEV, so we can say that the atomic and ionic radius will be smaller. The second factor will be shielding effect or screening effect. So this shielding effect is caused by the inner electrons in one atom or ion. So the inner electron will shield the valence electron from the nucleus attraction. So di sini, lagi banyak shielding effect, lagi besar sesuatu atom dan juga ion. Kenapa? Kerana inner electron melindungi valence electron daripada ditarik oleh nucleus. So, we are going to use these two factors in our explanation in order to discuss each of the categories. Now, let us discuss the first category, that is ionic radius as compared to its neutral atom. So, sekarang kita nak tengok size of ion jika dibandingkan dengan size of neutral atom. So, what you can see from this image? Here, we have the red one is the cation, and the grey one here is the atom of the cation. And the blue sphere here refers to the anion, and the grey part here is its atom. So in general, we can see that the size of the cation is smaller than its neutral atom. Okay, so ini adalah size untuk lithium plus ion, dan ini adalah size lithium atom. So size of the cation is smaller than the neutral atom. Berbeza dengan this anion and its neutral atom. The size of the anion here is bigger than the size of the neutral atom. So now we are going to discuss why does the size of the cation is smaller than its atom and why does the size of the anion is bigger than its atom. Let's take lithium atom as the example. So here is the electronic configuration of the lithium atom, that is 1s2, 2s1. So 2s1 is the valence configuration, and we have one electron in this valence shell. So after lithium atom removing this one valence electron, then we will get lithium ion, lithium plus ion, okay, that is the cation. So as you can see in the new electronic configuration of lithium ion, it has one s2. So, electron at valence shell in atom is removed to form positive ion or cation. So here, total electron in cation decreases. Hence, electron-electron repulsion decreases. So as you compare the total number of electrons in lithium atom and lithium cation, you can see here we have 3 electrons in atom and 2 electrons in cation. So apabila number of electron berkurangan, maka electron-electron repulsion pun akan berkurangan kerana kita ada smaller value of electron. So apabila less electron, kuranglah electron-electron repulsion between electrons. Electrons in cation experience a greater attractive force towards the nucleus. So here, in lithium atom, we have as much as 2 orbitals. But in lithium plus cation, kita hanya ada 1 orbital sahaja. So, the smaller the orbital, the closer the distance between the nucleus and the valence shell. Kedudukan di antara valence shell dengan nucleus adalah semakin dekat. So, ini akan menyebabkan electrons in cation experience greater attractive force towards the nucleus. Okay, elektron pada valence shell ini akan lebih mudah tertarik ke arah nucleus. So, remaining electrons are pulled closer to the nucleus. Remaining electron and the valence shell will be attracted to the nucleus, closer to the nucleus. So, hence, positive ion, that is cation, will be smaller than its atom. So, from this explanation, we can see that at this point, it has something to do with Zeph. So, this is the way we explain the variations of the cation size as compared to its atom. So, in general, cations are always smaller than the original neutral atom due to loss of electron. So, in this case, the size of the lithium plus cation will be smaller than the original neutral atom. In comparing the size of the anion to its neutral atom, let's take fluorine as the example. So, in this fluorine, we have 2s2 2p5 valence electronic configuration. So, meaning that in fluorine atom, we have as much as 7 valence electron. After this fluorine accept 1 electron to achieve octet stability, so the new electronic configuration for F-, which is anion, will be 2s2 2p6. So here, by receiving 1 electron, the total number of electrons at valence configuration of F- will be 8 electrons. So any outside electron is added to the valence shell of atom to form negative ion, that is anion. So elektron yang daripada luar tu tadi ditambah masuk ke dalam valence shell. Total electrons in anion will be increases. So hence electron-electron repulsion will be increases. So as we compare the total of valence electron di dalam fluorine atom, kita hanya ada sebanyak 7 elektron. But after the fluorine atom accept additional electron, so now the total valence electron in this valence shell akan menjadi 8 elektron. So in this case, total electron in an ion increases. Apabila elektron dah bertambah banyak, maka electron-electron repulsion pun akan bertambah. So di sini, apabila elektron yang ditambah tadi dimasukkan pada valence shell, maka akan wujud juga mutual electron-electron repulsion on the valence shell. So, since the electron-electron repulsion between electron increases, hence electrons will experience a weaker attractive force to the nucleus. Disebabkan daya tolakkan di antara sesama elektron itu lebih kuat, maka daya tolakkan ini akan mengatasi daya tarikan between the valence electron and the nucleus. So now daya tarikan between these two akan menjadi lemah. So remaining electrons are pushed away from the nucleus. Disebabkan tarikan antara nucleus dengan valence electron and valence shell adalah lemah, maka remaining electrons are pushed away. Okay, ditolak keluar, menjauhi nucleus. So negative ion or anion is bigger than its atom. So in this explanation, our main factor or main point adalah electron-electron repulsion. As the conclusion, size of the anions are always larger than the original neutral atom due to gain of electron. So the size of the F- anion will be larger than its original atom. Now, let's discuss the other category, that is variation in radius of isoelectronic species. So what is isoelectronic species? Isoelectronic species refers to atoms or ions with the same electronic configuration, that is having the same number of electrons. So the term atoms here are referring to noble gaseous atom, which is group 18 elements. And the ions here are referring to both cation and anion. So for the noble gases atom and cation and ion that having the same electronic configuration, they are called as isoelectronic species. So here we have period 2 and period 3 elements or atoms with their respective ion. So adakah semua ion in period 2 ini mempunyai elektron configuration yang sama? Ataupun adakah kesemua ion di dalam period 3 ini mempunyai same electron configuration? The answer is no. Hanya lithium plus, beryllium 2 plus and boron 3 plus sahaja yang mempunyai same electronic configuration for this cation. Meanwhile, O2 minus and F minus will have the same electron configuration. But electron configuration for these three cations in period 2 is not the same as the electronic configuration of this anion. Tak percaya? You can write the electronic configuration of the ion. Practice yourself. According to these ions in period 2 and period 3, we can see that O2 minus, F minus, sodium plus, magnesium 2 plus and aluminium 3 plus. These 5 ions will having the same electronic configuration, that is 1s2, 2s2 and 2p6. So, bermaksud ion-ion ini memandangkan mereka mempunyai electron configuration yang sama, maka these ions are called isoelectronic species. So here, for these two anions, they are formed by receiving electrons. And for these three cations, they will form by donating electrons from their neutral atom. So by accepting electrons and by removing electrons here, maka the final electronic configuration of their ion akan becoming like this, which is 1s2, 2s2, 2p6. So you can check by writing the electronic configuration for each one of this ion. Okay, you will find out yang mana kesemua electron configuration mereka ini adalah sama, iaitu 1s2, 2s2, 2p6. So what we can see from this arrangement, for isoelectronic ions, the more positive the cation, the smaller the radius. So you can see from this arrangement, from sodium plus moving to magnesium 2 plus and aluminium 3 plus. So the red sphere here is decreases in their size, menunjukkan bahawa as the positive charge increases, so the smaller the ionic radius. And for the anion here, the more negative the charge, the bigger the radius. Okay, so here we have oxygen 2 minus dan juga F minus. Mana yang lebih negatif? O2 minus is more negative. So the more negative the negative charge, or the more negative the anion, the bigger the radius. For isoelectronic species above here, their ionic radius or ionic size will be decreases in this arrangement. So O2 minus will has the bigger ionic radius, meanwhile aluminium 3 plus will has the smaller ionic radius. And we have neon at the center here to separate between the size of the anion and the size of the cation. Sebab secara generalnya, size of anion will be bigger than the size of the cation. So between these two anion, the greater the negative charge, the greater the size of the anion. And between these cations, the greater the positive charge in the cation, the smaller the ionic radius. Here in this table, you can see the variations of the ionic and atomic radius of isoelectronic species. So for O2-, its ionic radius is the highest as compared to the other atomic radius value. And for aluminium 3+, its ionic radius is the smallest. So they are isoelectronic because they have the same number of electrons. So we can get this number of electrons from their electronic configuration. Okay, electronic configuration for isoelectronic, that is 1s2, 2s2, 2p6. And from oxygen 2- to aluminium 3+, we can see that the number of proton is increases. So hence the nuclear charge also increases. And by calculating the effective nuclear charge ZEF pun sama, kita akan observe the increase in the ZEF value. So still remember how to calculate the ZEF? So for isoelectronic ion, proton number increases from O2- to aluminium 3+. So from 8 increases to 13. So by increasing the proton number, so of course effective nuclear charge ZEF also will be increases. So ingat balik, apabila ZEF value increases, so attraction force between remaining electrons and nucleus will increases ataupun stronger. So ini akan menyebabkan valence shell will be attracted closer to the nucleus. So hence the ionic radius will be smaller. So this is the reason kenapa aluminium 3+ ini mempunyai ionic radius yang paling kecil, disebabkan oleh nilai ZEF dan juga nuclear charge-nya yang tinggi. So apabila awak nak buat susunan of isoelectronic species dalam bentuk decreases order macam ini, so please make sure awak susun anion dahulu and letakkan noble gas di tengah untuk memisahkan di antara anion dan juga cation. So di dalam arrangement of this anion, baru awak susun antara O2- and F-. Okay, mana yang lebih besar? So definitely the more the negative charge, the bigger the ionic radius. The more negative the charge in this oxygen menunjukkan bahawa the value of the effective nuclear charge ZEF will be the lowest. So nilai ZEF yang lowest ini menunjukkan bahawa attraction force between remaining electron and nucleus is the weakest. So tarikan yang weakest di antara remaining electron and nucleus ini yang akan menyebabkan ionic radius of O2- ini akan menjadi the biggest ataupun highest. So after that, barulah awak mula menyusun pula untuk cation. So dalam arrangement of the cation, the more positive the value of the cation, so this will be the smallest cation, the smallest radius. So that's why kita akan susun bermula daripada +1, 2+, dan juga 3+. The more positive the cation, ini bermaksud the value of the effective nuclear charge ZEF is the highest. So value ZEF yang highest ini merujuk kepada stronger attraction forces between remaining electron and nucleus. So apabila tarikan between them adalah the strongest, maka ini yang akan menyebabkan size of this cation will be the smallest. Now, let us study the variation in ionic radius across period 2 and 3. So here we have the elements, the atoms and ions for period 2, and here are for period 3. So the blue one here refers to the atom, and the grey color refers to the cation. And the brown here refers to the atom, And the grey color here refers to the anion. So basically, cation is smaller than its atom. And for anion, it is bigger than its atom. So that's why awak nampak yang grey ni lebih besar daripada yang brown. Dan untuk cation ni, okay, yang warna biru lebih besar daripada warna grey. Sebab grey ini merujuk kepada ions. So, can you see the trend of ionic radius across period 2 and period 3? For this cation, we can see that the size of the cation will be decreases from left to right. And for this anions as well, the size of the ion will be decreases from left to the right. But moving from this cation size to this anion size, we can see that there is a drastic changes in ionic radius from this cation to this anion. And you will see the same trend in the period 3 as well. So in this category, we will study kenapa size of the cation decreases from left to right dan kenapa size of anion pun will decreases from left to right dan kenapa size of this cation dan anion ini berubah secara drastic. The variation of the ionic radius across period 2 and period 3 just now can be explained by using this graph. So in order to discuss the variation, okay, nak discuss perubahan of the ionic radius across period 2 and 3, kita akan pecahkan kepada 3 bahagian. Okay, yang pertama, ionic radius among the cation, okay, for period 2 dan juga period 3. Yang kedua, the drastic increase between cation and ion for each period here. And the last part will be the changes in ionic radius for the anions. Bahagian yang pertama, kita akan bincangkan tentang ionic radius of cation for period 2 and period 3. So, from the shape of the graph, kita boleh nampak bahawa as the charge positive increases, the cation size will be decreases or smaller. So trend yang sama dapat kita perhatikan juga untuk period 3. So as the positive charge increases, the size of the cation will be decreases. So for this trend, ionic radius decreases from lithium plus to boron 3 plus in period 2 and sodium plus to silicon 4 plus in period 3. So what is the reason? For period 2, these cations are isoelectronic because they have the same electronic configuration, that is 1s2. And for period 3, these ions are also isoelectronic because they have the same electronic configuration and the same number of electrons, that is 10. So from 1s2 to s2 to p6. Moving from lithium in group 1 to boron in group 13 and also from sodium group 1 to silicon group 14, proton number will be increases. So apabila proton number increases, definitely effective nuclear charge ZeV will be increases. So attraction between nucleus and valence electron will become stronger, hence the ionic size will be decreases. So the main factor that affecting the size of the cation for period 2 and period 3 adalah ZeV. The more positive the charge of the cation, the greater the effective nuclear charge, the stronger the attraction forces between the nucleus and valence electron or remaining electron. So hence ionic size untuk cation akan semakin kecil dengan pertambahan charge positif. Dalam bahagian yang kedua, we are going to discuss the drastic changes between boron 3 plus and N3 minus dalam period 2 dan juga between silicon 4 plus ion and phosphorus 3 minus in period 3. So at this area, we can see there is a drastic increase in ionic size from boron 3 plus to nitrogen 3 minus. Okay, kenapa boleh jadi macam ni? Disebabkan oleh nitrogen ion has additional shell, that is 1s2, 2s2, 2p6 berbanding boron 3 plus yang hanya ada 1s2 sahaja. So these two are the ionic electron configuration. Okay, elektron konfigurasi untuk ion tersebut. So electrons in
N3- ion
are shielded by 2 inner electrons, but in boron 3+, it has no inner electrons. So this could be seen from this electronic configuration.
dalam N3- kita ada
2s2 and 2p6. Ini sebagai valence configuration. Okay, dan kita ada 1s2 ini sebagai inner electron. Tetapi di dalam boron 3+, we don't have any inner electron. So, memandangkan nitrogen ion has inner electron, so shielding effect in nitrogen ion is greater. So, this shielding effect akan menyebabkan attraction between nucleus and valence electron becomes weaker in nitrogen ion. So, ionic radius of nitrogen ion is larger than boron 3+. And at the same area, in period 3 juga, kita akan fokus perubahan of ionic size between silicon 4+ and phosphorus 3-. So you can see a huge ataupun drastic increase between these two here. Kenapa ini boleh terjadi? So definitely reason dia sama juga macam period 2 just now. So phosphorus 3- has additional shell. So this will be the ionic configuration for the phosphorus ion, 1s2, 2s2, 2p6, 3s2, 3p6. Then silicon 4+, okay, yang hanya mempunyai this electron configuration for ion. So electron in P3- are shielded by 10 inner electrons than silicon 4+ that has 2 inner electron only. So from here, you boleh tengok dalam ionic configuration of this phosphorus, so these two orbitals merujuk kepada valence shell. So yang mana satu inner shell? Ini adalah inner shell untuk phosphorus. Berapa elektron? Ada 10 inner elektron di situ. Dan untuk silicon 4+, 2s2, 2p6 merujuk kepada valence shell. So core shell ataupun inner shell hanyalah merujuk kepada 1s2 sahaja. So how many electrons pada inner shell? Kita hanya ada sebanyak 2 elektron. So seems there are many inner electrons di dalam
phosphorus ion.
So shielding effect in phosphorus ion is greater than silicon 4+. Okay, so this shielding effect akan menyebabkan attraction between nucleus and valence electron becomes weaker in phosphorus ion. So at this point, valence electron and valence shell of the phosphorus ion will be pushed away from the nucleus. So itu yang akan menyebabkan ionic radius for phosphorus ion is larger than silicon 4+. In the last part here, we are going to discuss the variation of the anion across the period. So for period 2 and period 3 here, we can see that the size of the anion will be decreases as the negative charge decreases. So ionic radius decreases from sodium. Ionic radius decreases from nitrogen ion to fluorine ion and from phosphorus to chlorine ion. So for period 2 and ions here, these ions are isoelectronic, okay, because they have the same electronic configuration like this. And for this ion in period 3 as well, they are isoelectronic because they have this same electronic configuration. So again, to explain the variations of the anion across the period, we will use the same explanation like what we did for the cation. So moving from nitrogen to fluorine ion and phosphorus to chlorine ion, proton number will be increases. So when the proton number increases, so definitely effective nuclear charge ZeV will be increases. So ZeV increases menunjukkan bahawa from the more negative ion to less negative ion, attraction between the remaining electron here with the nucleus will be stronger or increases. Oleh itu, their valence shell and valence electron will be attracted more to the nucleus. So ini yang akan menyebabkan going from left to the right of the anion region, the ionic size will be decreases. As the conclusion, the more negative the charge of the anion, the bigger the size of the anion. So with more electrons, the attraction between nucleus and remaining electrons will be weaker. So, 3 bahagian tadi sepatutnya sudah menerangkan kepada kamu tentang perubahan of the ionic radius across period 2 and period 3. So, ingat kita ada 3 bahagian tadi. The first bahagian adalah untuk ionic radius decreases among the cation for each period, for both period. Dan part yang kedua untuk menerangkan tentang drastic increase from the cation and anion for both period as well. And the last part has been discussed with you tentang ionic radius yang decrease, okay, among the anion for period 2 and then juga period 3. The last category will be the variation in ionic radius down or descending a group. So here you can see the variations of the ionic size, okay, going down a group. So kita ada cation group 2, anion group 16 dan anion group 17. So for here, in here you boleh nampak yang warna pink ini merujuk kepada cation lah. Okay, so yang biru ni merujuk kepada anion group 16 dan yang biru ini juga merujuk kepada anion untuk group 17. So for the trend of the anion dan juga cation size, bila kita turun kumpulan, you boleh nampak the size of the ion will be increases. Okay, tak kira lah sama ada cation ataupun anion. Okay, kenapa jadi macam tu? Kerana going down a group, the principal quantum number n increases. So apabila n increases, definitely shielding effect will be increases. So valence electron are less attracted to the nucleus. So ionic size will be increases as going down a group. So untuk faktor yang menerangkan tentang variation of ionic radius down a group adalah shielding effect. So the more the electrons in the principal quantum number, the greater the shielding effect. So lagi banyaklah inner electron boleh halang daya tarikan antara nukleus dengan valence electron. So bila tarikan itu lemah, maka the outer orbital or the valence electron akan expand keluar. Okay, so itu yang akan menyebabkan ionic size increases going down a group.